Children, let me take up one more numerical for you. Calculate EMF and delta G for the following. Ni bar Ni2 plus of a 0.01 molar concentration, double bar Ag plus of 0.01 molar concentration bar Ag. Given standard reduction potential of Na2 plus bar Ni is equal to minus 0.25 volts and standard reduction potential of Ag plus bar Ag is equal to 0.80 volts. Children, remember, for finding the EMF of a cell, you need to know E0 cell as well as number of electrons required for the reduction process. For that, first I need to write the cell reaction, find out the E0 cell, and then I'll proceed for finding the EMF and later delta G. Children, let me solve the numerical. Let me write anodic as well as cathodic reaction. Children, from this cell representation, you can easily identify which is anode and which is cathode. A, B, C. A stands for anode, B stands for salt bridge, C stands for cathode. Is it not? Now, let me write. Nickel undergo oxidation by losing 2 electrons. Children, at cathode, Ag plus takes up the electron and get reduced to Ag. Now, in order to balance, I multiply the cathodic reaction by 2. Cancel. Now, let me write the overall reaction. Look at here. Ni plus 2Ag plus giving rise to Ni2 plus 2Ag. Children, this is what the overall reaction. Now, let me find out E0 cell. Children, E0 cell is equal to E0 cathode minus E0 anode. Or you can say that E0 right minus E0 left. What is cathode here, children? Cathode is Ag plus bar Ag. Now, what is the value here? 0.80 minus anode is Na bar Na2 plus, reduction potential is given, minus 0.25 volts. Now, if I simplify, I am going to get plus 1.05 volts. Children, so this is what E0 cell value. Now, let me find out N. Children, 2 electrons are required for the reduction of 2Ag plus 2Ag. Is it not? So, N is equal to how much? N is equal to 2. Once you find out E0 cell and N, let me find out E cell with the expression E cell is equal to E0 cell minus 0.0591 upon N into log of concentration of products upon concentration of reactants. Children, look at here. These two are the products and these two are the reactants. E0 cell minus 0.0591 upon N into log of molar concentration of Ni2 plus into concentration of Ag raised to 2 upon molar concentration of Ag plus raised to 2 into molar concentration of Ni. Children, you know that active mass of any metal is equal to how much? 1. Put 1 here, 1 square, again it's 1 only. Now look at here. Let me substitute the value. Children, E0 cell is equal to 1.05 minus 0.0591 and number of electrons required for the reduction process N is equal to 2 into log of, look at here, Na2 plus molar concentration is equal to how much here? It is 0.01 upon molar concentration of Ag plus how much it is? 0.001 whole square. Children, let me simplify. 1.05 minus 0.0591 upon 2 into log of, look at here, I can write 10 to the power of minus 2. Here I'll write 10 to the power of minus 6. Is it not? So this I'll take it to numerator. What I'll get? 1.05, 0.0591 upon 2 into log of, look at here, 10 to the power of 6 will go to numerator. In that case, log 10 to the power of 4. Now this I can write, look at here, how do I write? You know that log a to the power of n is equal to n log a. Is it not? The same law apply here. 1.05, 0.0591 upon 2 into log of, look at here, 10 to the power 4, I can write log 10 is 4 log 10. 4 log 10, is it not? And remember, log 10 is always is equal to 1. Log 10 is equal to 1. In that case, please look at here, 1.05 minus 0.0591 upon 2 into 4. Why? Because log 10 is equal to 1. Now I'll do 2's and if you simplify, children, 1.05 minus 0.1182, that is equal to 0.9318 volts. So this is what, children, E cell. Hope you got it. Now once you find out E cell, next we'll go for what is that? Delta G. What is delta G? Look at here. Delta G is nothing but Gibbs energy change. And formula you know that, minus NF E cell. Is it not? Minus N is how much here? N is nothing but 2. And Faraday you know that, 96,500 joules into E cell, just now you have calculated, that is equal to 0.9318 volts. Children, if you simplify, you are going to get minus 179,831 joules. So this is what delta G. I simplify, delta G is equal to minus 179.8 into, kilojoules per mole. This is also per mole. So this is how you have to find out delta G. Children, let me take up one more numerical of the same type. Calculate the cell EMF and delta G for the following. Zn bar Zn2 plus of molar concentration is 0.0004 molar double bar, Cd2 plus of molar concentration 0.2 molar bar Cd. Given standard reduction potential of Zn2 plus bar Zn is equal to minus 0.763 volts and standard reduction potential of Cd2 plus bar Cd is equal to minus 0.403 volt. Given log 2 is equal to 0.3010. Children, let me solve the numerical for you. As usual, what you have done in the previous numerical, first I will write anodic and cathodic reaction. And how do I find cathode and anode? By using ABC. ABC. A stands for anode, B stands for salt bridge, C stands for cathode. Now anode, look at here, zinc loses 2 electrons and forms Zn2 plus ion, whereas Cd2 plus ion, cadmium 2 plus ions, takes up 2 electron and get reduced to Cd. If I want to write overall reaction, I would write Zn plus Cd2 plus giving rise to Zn2 plus Cd. Children, in this case you can find out N is equal to 2. Tell me why? For the reduction of 1 mole of Cd2 plus ions to Cd, we require 2 moles of electrons. That is why N is equal to 2. Now let me find out E naught cell. Now E naught cell is equal to E naught cathode minus E naught anode. Is it not? E naught cathode, which is the cathode here, children, Cd2 plus bar Cd. What is the value here? Minus 0.403 of minus. Anode is what? This is what the anode here, minus 0.763. If you simplify, you are going to get plus 0.360 volts. So this is not E naught cell. Children, once you find out E naught cell, let me go for E cell. Now E cell is nothing but EMF of the cell is equal to E naught cell minus 0.0591 upon N into log of active mass, the product, upon active mass of the reactants. Is it not? Now let me write E naught cell minus 0.0591 upon N into log of, which are the product? So these two are the products here. So how do I write? Molar concentration of Zn2 plus into concentration of CD upon molar concentration of a CD2 plus into concentration of zinc, and concentration of a zinc is equal to concentration of CD, it is equal to 1, or in general active mass of any metal is equal to 1. Children, in that case, look at here, E naught cell is how much here? 0.360 minus 0.0591 upon 2 into log of, let me write the concentration of Zn2 plus ions. Zn2 plus ion is equal to 0.0004 upon molar concentration of CD2 plus, that is equal to 0.2. Children, how do I write? Look at here, 0.360 minus 0.0591 upon 2 into log of, look at here, I can write this as 4 into 10 to the power of minus 4. Is it not? I change the decimal place, upon 2 into 10 to the power of minus 1. Hope you are getting right. Now 2 2s are, and this if I take it to numerator, then that will become 10 to the power of minus 3. Hope you got it. Now look at here, 0.360 minus 0.0591 upon 2. Children, look at here, log 2 into log 10 to the power of minus 3. So how do I write this? Look at here, 0.360 minus 0.0591 upon 2 into log 2 plus minus 3 log 10. Why? Because log m into n is equal to log m plus log n. Hope you got it. Now log 10 is equal to how much? 1. Is it not? Now look at here, 0.360 minus 0.0591 upon 2 into log 2 value is given. How much? It is 0.3010. Look at here, log 10 is equal to how much? Log 10 is equal to 1. So 1 into minus 3 is minus 3 only, minus 3. Hope you got it. Right? Now look at here, 0.360 minus 0.0591 upon 2 into, children, minus 2.699. Okay, if you subtract this, you will get the value. Hope you got it. Now let me continue. If I continue, and I am going to get, look at here, 0.4397. This is what? E cell. This is what? E cell value. If you simplify, you are going to get 0.4397, that is E cell value. The unit is volts. Children, once you get the E cell, now I will go for delta G is equal to minus N into F into E cell. Now minus N is how much here? N is equal to 2. Is it not? 2 into 96,500 into E cell is how much here? E cell is equal to 0.4397 volts. Hope you are following. Children, if you simplify, you are going to get minus 84.862 joules per mole, or you can simplify, delta G is equal to minus 848.6 kilojoules per mole. So this is already calculated and directly I am writing there. Hope you got it, but you should be very careful in this part. Children, let me take up one more numerical of the same type, because these are the numerical which are very important, and nowadays you get many numerical in the board examination of this type. Children, let me take up one more numerical. Write the Nernst equation and calculate EMF of the following at 298 Kelvin. Cu bar Cu2 plus of molar concentration 0.130 molar, double bar Ag plus of molar concentration 1 into 10 to the power of minus 4 molar concentration bar Ag, given standard reduction potential of Cu2 plus bar Cu is equal to 0.34 volts and standard reduction potential of Ag plus bar Ag is equal to 0.80 volts. Children, as usual, we need to find out A naught cell and number of electrons required for the reduction of 1 mole of certain species, and then you can find out E cell. Let me take up. Solution. Let me write anode as well as cathode reactions. Look at here, this is what the cell representation A, B, C. A stands for anode, B stands for salt bridge, C stands for cathode, is it not? Now look at here, at anode, Cu loses 2 electrons to form Cu2 plus, whereas at cathode we have Ag plus takes up electron and get reduced to Ag. Children, what I do, I balance the number of electrons by multiplying the cathodic reaction by 2. Now I'll cancel these 2. Look at here, Cu plus 2Ag plus giving rise to Cu2 plus 2Ag. Remember, if you do not multiply by 2, you will go wrong, because you will take number of electrons for the reduction as only 1. But in this case, you know that N is equal to 2, because 2 moles of electrons are required for reduction of 2Ag plus 2Ag. So in that way you can calculate En. And let me go for E naught cell. E naught cell is equal to E naught cathode minus E naught anode. E naught cathode, children, this is what the cathode, right? So 0.80 minus, so anode is 0.34. So you are going to get 0.46 volts. This is what E naught cell. Children, once you write, E naught cell as well as N value, now you can easily write Nernst equation. How do I write Nernst equation? You know that E cell is equal to E naught cell minus 0.0591 upon En into log of active mass of the products upon active mass of the reactants. Is it not? Now look at here, this is what the cell reaction, is it not? E naught cell minus 0.0591 upon N into log of products. So we have Cu2 plus into Ag raised to 2. Okay, now reactants, we have concentration of Cu into concentration of Ag plus raised to 2. Children, so this is what Nernst equation. This is what Nernst equation, right? Now look at here, E cell is equal to E naught cell minus 0.0591 upon N. Look at here, log of, children, Cu2 plus upon Ag plus whole square, because concentration of a Cu is equal to concentration of Ag is equal to 1. So 1 square is also 1. So now let me substitute the value. E naught is equal to how much? 0.46 volts minus 0.0591 upon 2 into log of, children, Cu2 plus ion concentration, it is 0.130 upon, children, Ag plus whole square, it is equal to 1 into 10 to the power minus 4 whole square. Now what do I do? Look at here, 0.46 minus 0.0591 upon 2 into log of, look at here, in this case 0.130, I'll keep it as it is. Here I'll write as 10 to the power minus 8 because it's whole square. Hope you got it, right? Now let me continue. 0.46 minus 0.0591 upon 2 into log of, children, look at here, 0.130 into 10 to the power of minus 8, it will become plus 8, 10 to the power of 8. Is it not? Now, look at here. Now I'll go for log m into n, that is log m plus log n, log. Okay. Now 0.406, 0.0591 upon 2. Children, here you should be very careful, into log 13. Got it? Plus, children, look at here. Now what did I do? I change the decimal place here, right? Then it will become 10 to 13 into 10 to the power minus 2. 10 to the power minus 2 here, 10 to the power 8. That will become what? Look at here, log of 10 to the power of 6. Hope you understand that. Look at here, I change the decimal place. 0.30, I change to 13 into 10 to the power minus 2. Now I have 10 to the power 8. Right? So instead of that, look at here, log 13 plus, right, log of 10 to the power of 6, because 10 to the power minus 2, 8, 8 minus 2, 6. That I have taken. Hope you got it. Children, once you write, look at here, let me proceed. 0.46 minus 0.0591 upon 2. Look at here, into log 13, children, the log 13 value is 1.1139, right? Plus, look at here, what do I do? Plus, this can I write, look at here, log 10 to the power 6, I can write 6 log 10, is it not? 6 log 10 is what? Log 10 is equal to 1, that is equal to 6. The entire log 10 to the power 6 I will write as how much? 6 plus 6. Hope you got it. Now 0.46 minus 0.0591 upon 2 into, look at here, 7.1139. Children, hope you understand that, right? Now if you simplify, you are going to get, look at here, E cell is equal to 0.2498 volts. Simplify that, you are going to get around 0.2498 volts. Children, this is how you are supposed to solve the numerical where they ask you to find out E cell of a given cell. Children, let me take up one more numerical. Represent a cell in which the following reaction takes place: Mg plus 2Ag plus giving rise to Mg2 plus 2Ag. Calculate its E cell if E naught cell is equal to 3.17 volts. Now no need to find out E naught cell, they are already given the E naught cell. Solution. Children, first I need to write the anode reaction and then I'll write the cathode reaction. Look at here, anode. Mg from zero oxidation state is getting converted into 2 plus oxidation state. That means increase in oxidation state. What do you call that? Oxidation. That means Mg loses 2 electrons to form Mg2 plus. So this is what the anodic reaction. And look at here, Ag plus takes up the electron and get reduced to Ag. Children, look at here, from +1 oxidation state it becoming 0. The decrease in oxidation state, what do you call this? Reduction. Now look at here, children, cathode, Ag plus takes up electron to form Ag. Now look at here, this should be multiplied by 2, right? Now your overall reaction will be, look at here, Mg plus 2Ag plus giving rise to Mg2 plus 2Ag. Is it not? This is overall reaction. Now I can represent the cell. How do you represent? You know, A, B, C. A stands for anode, C stands for cathode. Let me write anodic reaction, other is cathodic reaction. How do you represent? Look at here. Anode is what? Anode is Mg, right? Mg, solid state, ionic state. Concentration is given. How much it is? 0.130 molar. Double bar, salt bridge. Let me write the cathodic. Cathodic, first you have to write the ions. So we have Ag plus, what the concentration here? Ag is equal to Ag plus 0.0001 molar. So this is what? Cell representation. Hope you got it. Now children, once the cell representation is over, now find out N here. N is what? Number of electrons required for the reduction process. Look at here, for the reduction of 2 moles of electrons, Ag plus ions to Ag, you require 2 moles of electrons. That means N is equal to 2. N is equal to 2. Now let me write Nernst equation. E cell is equal to E naught cell minus 0.0591 upon N into log of active mass of products upon active mass of reactants. Is it not? Look at here, E naught cell minus 0.0591 upon N into log of products. Look at here, Mg2 plus, Mg2 plus concentration into Ag whole square upon, look at here, Ag plus whole square into concentration of Mg. Children, concentration of Mg is equal to concentration of Ag is equal to 1, or active mass or the concentration of any metal is equal to 1. Now look at here, how to write E naught cell minus 0.0591 upon N is equal to log of Mg2 plus concentration. How much? It is 0.130. Is it not? Upon concentration of Ag2 plus, it is 0.0001 whole square. Now children, how do E naught cell is given? How much? E naught cell, how much? It is 3.17 volts minus 0.0591 upon 2. Look at here, log, how do you write? Log 13, reshuffle the decimal place, 13 into 10 to the power of minus 2, right? Now this one, look at here, it will become 10 to the power of minus 8, right? Now 3.17 minus 0.591 upon 2 log 13 into, if it go in the numerator, 10 to the power of 6. So you can write 3.17 minus 0.0591 upon 2. Look, log 13, right? Value you have to find out, plus 6 log 10. Children, in this case, log 13, you know the value, 1.1139 plus 6 is similar to that of the numerical which I solved earlier. Hope you can continue. Okay, so continue and find out the E cell value. Children, let me take up one more numerical. A voltaic cell is set up at 25 degrees Celsius with the following of cells: Al3 plus 0.001 molar and Na2 plus 0.50 molar. Write an equation for the reaction that occurs when the cell generates an electric current and cell potential given standard reduction potential of Na2 plus bar Na is equal to minus 0.25 volts. Standard reduction potential of Al3 plus bar Al is equal to minus 1.66 volts. Children, let me solve this numerical solution. Let me write the anodic and cathodic reaction so that we can write the entire cell reaction which takes place in this cell having two off cells. Children, look at here. Al convert into Al3 plus ions by losing electrons. What do you call that? Oxidation. Look at here. Al get converted into Al3 plus, giving rise to 3 electrons. Now similarly, other side we have nickel. Nickel 2 plus takes up 2 electrons and get converted into nickel. Is it not? Now children, I should balance number of electrons. How do I do? Look at here. I multiply the anodic reaction by 2 and cathodic reaction by 3. In that case, look at here. 3 into 2, 6 electrons. Here, 2 into 3, 6 electrons. I get cancelled. So 2Al plus 3 Ni2 plus, giving rise to 2Al3 plus 3 Ni. So this is what the overall reaction that takes place in the cell. Hope you got it. Now children, now tell me what is the N value here? Children, N is equal to, look at here, 2 into 3, 6 electrons, or 3 into 2, 6 electrons. So 6, N is equal to 6. Children, once you find out that, I can find out E naught cell also. E naught right or cathode minus E naught left or anode. Children, E naught cathode, this is Na2 plus bar Ni, that is equal to minus 0.25 volts minus of anode, that is Al3 plus bar Al minus 1.66 volts. Children, you are going to get plus 1.41 volts. So this is what E naught cell. So you have calculated N and E naught. Now what is left out? Now we need to find out E cell. So with the expression, the last expression, E naught cell minus 0.0591 upon N into log of products upon the reactants. Right? Now E naught cell minus 0.0591 upon N into log of. Children, which are the products here? Look at here. These two are the products. Right? I will not consider this because active mass of nickel is equal to 1 and directly write Al3 plus. Al3 plus, what is that? Whole square upon the reactant. In the reactant side, look at here, aluminum is there. Aluminium, metal, and concentration of metal is equal to 1. 1 square doesn't make any sense there. So I'll go for nickel Ni2 plus whole cube. Right? Now E naught cell. Let me put the E naught cell value. How much it is? 1.41. Is it not? Minus 0.0591 upon 6. N is equal to 6. Log of. Children, look at here. Al3 plus, what is the concentration? Yeah, 0.001 square upon nickel. How much? 0.50 whole cube. Is it not? Whole cube. Now look at here. 1.41 minus 0.0591 upon 6 log of. This I'll write as 10 to the power minus 6. Hope you got it. Now if you simplify, you're going to get 0.125. So how do I write? 1.41 minus 0.0591 upon 6. Look at here children, log, is it not? 10 to the power minus 6. So upon, look at this, how do I write that? 12.5 into 10 to the power minus 2. I change the decimal place. Look at here, in that case 1.41 minus 0.0591 upon 6 into log of, children, look at here, if I take this to the numerator, it becomes plus 2, is it not? It becomes plus 2. What will happen? Log 10 to the power of 4, sorry, minus 4 into log of 12.5. Children, 1.41 plus, sorry, minus 0.0591 upon 6 into, look at here, this will become minus 4 log 10 is equal to how much? Log 10 is equal to, otherwise I'll write log 10 plus log 12.5. Hope I can write, right? Now what I'll write, look at here, 1.41 minus 0.0591 upon 6 into log 10 is equal to 1. So minus 4. You find out log 12.5. Okay. Now you find out that the remaining thing you can easily proceed, and the end you find out what is the E cell value. Hope you got it. Let me stop. The further calculation you do it on your own. Children, let me take up one more numerical which has been asked in the board examination. I believe it is in 2018. For the reaction 2AgCl solid plus H2 gas giving rise to 2Ag solid plus 2H plus ions 0.1 molar concentration plus 2Cl minus ions 0.1 molar concentration. Given delta G naught is equal to minus 43,600 joules at 298 Kelvin or 25 degrees Celsius. Calculate EMF of cell. Children, for calculating E cell, you need to know E naught cell as well as N value. Is it not? For that, I need to write the anodic as well as the cathodic reaction. Let me solve. Solution. Anode. Children, look at here. Hydrogen's oxidation state is 0 because it is in the elemental form. It is getting converted into H plus ions. That means there is increase in oxidation state, and that is what you call this oxidation. Hope you got it. Whereas, look at here. In the case of silver, it is in Ag plus, but it is in solid state. Is it not? It is getting converted into Ag plus 1 state to 0. That means decrease in oxidation state or number, which you call it as reduction. Is it not? Now let me write anode. H2 getting converted into 2H plus ions plus 2 electrons are produced. Now cathode, children, look at here. This 2Ag plus takes up 2 electrons lost by the H2 to form 2Ag. Children, hope you understand that. Now N is equal to how many moles of electrons? 2 moles of electrons are required for the reduction of 2Ag plus 2Ag. Children, you know that E naught cell you can calculate by using the expression. Look at here, delta G naught is equal to minus N into F into E naught cell. Why? Because delta G naught value is given. So that is why I have taken this expression. Now look at here, E naught cell is equal to delta G naught upon N F. So minus sign is there. So minus into minus of 43,600 joules upon N is how much here? N is equal to 2 into 96,500. Children, if you simplify, you are going to get 0.226 volts. So this is what E naught cell. Children, you got E naught cell value as N value, and it is easy for me to go for E cell or EMF. E cell is equal to E naught cell minus 0.0591 upon N into log of active mass of products upon active mass of reactants. Is it not? Now E naught cell minus 0.0591 upon N log of. Children, look at the product. The product side we have, what is that? I will not consider this one because active mass of any metal is equal to 1. What do I consider? Only H plus ions whole square upon, look at here, in this case, no, Ag plus, I should have taken the Ag plus, children, but it is in the solid state. What do? I'll take Ag whole square. Again, you know, any metal concentration is equal to 1. 1 square, again it becomes 1. So let me write E naught cell minus 0.0591 upon N into log of. Children, H plus ion concentration is how much here? 0.1 whole square upon 1 whole square. Children, let me substitute the value. E naught cell is equal to how much? It is 0.226 minus 0.0591 upon N is how much? 2 into log of. This I'll write as 10 to the power of minus how much? 2. Hope you got it. And this 1 square is equal to much? 1 only. So what I do? 0.226 minus 0.0591 upon 2. Now this I will take minus into minus 2 into log 10. Children, log 10 is equal to 1. So what I do? 0.226 minus 0.0591 upon 2 into minus 2. Children, if you simplify, we are going to get E cell value. You simplify and find out the answer for that. Children, let me take up one of the question which was asked in the 2018 examination as a choice question. If a current of 0.5 amperes flows through a metallic wire for 2 hours, then how many electrons would flow through the wire? Children, let me solve this numerical solution. So what are the data given here? Given data. Look at here, I is equal to how much? 0.5 amperes, right? And T is given how much? It is 2 into, you know, you need to convert that into seconds. What I do, I'll put 3600 seconds, right? Now children, you know that. What is that? Q is equal to I into T. I is how much here? 0.5 into 2 into 3600. Now if you multiply 2 into 0.5, that is equal to 1. So 1 into 3600, otherwise 3600 coulombs. Hope you got it. Now children, you know that 96,400 coulombs, nothing but 1 Faraday, contains 6.022 into 10 to the power of 23 electrons. Is it not? In that case, 3,600 coulombs contains how many electrons? Children, we go for the cross multiplication. 6.022 into 10 to the power of 23 into 3600 upon 96,500. Children, if you do this, you are going to get 0.223 into 10 to the power of 23 electrons, or I can simplify it right? Look at here, 2.23 into 10 to the power of 22 electrons. So these many electrons will flow through the wire if the current passed through the wire is 0.5 amperes and it is for 2 hours. Children, let me take up the last numerical of this unity electrochemistry, which has been asked again in the examination. Suggest a way to determine limiting molar conductivity of water. Children, you can find out limiting molar conductivity of water by using Kohlrausch's law of independent migration of ions. Children, let me find out solution. According to Kohlrausch's laws, look at it, children. Limiting molar conductivity of water is equal to sum of the contribution of all the ions present in that electrolyte. Is it not? Now, how do I find out? Limiting molar conductivity of water is equal to limiting molar conductivity of hydrochloric acid, strong electrolyte, plus limiting molar conductivity of sodium hydroxide, again a strong electrolyte, minus limiting molar conductivity of NaCl, children, sodium chloride, again is a strong electrolyte. And you know that limiting molar conductivity of any strong electrolyte can be obtained by extending or extrapolation of the graph, which you get by plotting, lambda m versus square root of concentration. Children, what is extra here? Look at here, Cl is extra, Na is extra, is it not? H plus OH minus. So Cl is extra, Na is extra, I remove in the form of NaCl. Children, in that way you are going to get limiting molar conductivity of water. There ends this unit electrochemistry. Now let me go for the next unit, is chemical kinetics.